Okay, so now I will be explaining question 18. So the first important concept in question 18 is torque. Okay, so basically torque is a force that causes rotation. It is related to force for linear motion, but basically torque is the force for rotational motion. So in terms of this video in question, we're gonna say torque is equal to the change in angular momentum with respect to time. And this is similar to how in linear motion, force is equal to the change in linear momentum with respect to time. So that's how. So basically, torque will be the change in angular momentum. And it's related to that of linear momentum. Okay, so now, I'm also going to define moment of inertia, which is also related to rotation. So moment of inertia, we use it as I, and it's equal to mass times radius squared. So that is the definition for moment of inertia. Okay, so we're going to be using those two concepts for this question. So now I'm going to read question 18. The interval of time change in t is the elapsed time from the moment of first contact between the two disks until they are spinning at the same angular velocity. Which of the following expressions gives the magnitude of the average torque that the first disk exerts on the second disk? Okay, so basically it is looking for the torque. It's looking for the amount of torque, so the amount of change in angular momentum. So we can use this principle. Now for this question, there's two types of angular momentum, but in terms of this question, they're using the angular momentum is equal to moment of inertia times angular velocity. And so this is the angular momentum meant for when an object is just spinning around its own axes. So that's the one that we're going to use now. And so we're gonna use this principle to find the amount of torque. So first, we're gonna do the change in L with change in time. So change in angular momentum. So it shows above that I is equal to mr squared over 2. So we can put mr squared and then over 2 for here. And then then we have angular velocity, and remember we're looking for the change in it. So we're going to be looking at the final angular velocity minus the initial angular velocity. So since we're looking at the change in angular momentum, that's what it's going to be, and then times the change in time. Okay, so now we're going to look at it. So it's in this problem, it says gives the magnitude of the average torque that the first disk exerts on the second disk. So it states earlier in this question that the second disk is at rest. So that means that our initial angular velocity is going to be 0 because it's at rest, it's not moving. So then we can say that this is mr squared, and then the final angular velocity is when they're both moving together. So what we finally get is mr squared times angular velocity final is equal to 2 times the change in time. Okay, so that is our correct answer. And so that means that the correct answer to question 18 is C. And basically what this question showed is, for one, torque is equal to the change in angular momentum with respect to the change in time. That's just, there's other ways to use torque, but in terms of that, that's just the concept we are looking at right now. And that's also related to the linear side of that force is related to the change in momentum with respect to time. We also use that moment of inertia, I equals mr squared, and for angular momentum we used moment of inertia times angular velocity. And these concepts helped us solve question 18.